So, let us choose 2 points on the ray. Okay, on the ray x of z. So, this is actually 4 cross 1. Okay, when I say x of z, I mean that z k inverse x tilde or whatever k l inverse x tilde 1. Okay, that's x of z. So, the 1 point, right? So, 1 at z equal to 0, that is the camera center. See, the idea is that, right, you want to take see 2 points which are probably, right, easy to handle rather than right taking up anything which is arbitrarily there on that line. So, one at say z equal to 0 and the other at z equal to infinity, that is a point at infinity. Okay, on that ray, right, on that see back with this one projected ray. So, for z equal to 0, right, your x of z will look like 0 0 0 1, right, because your z is bang at your point is bang at the camera center. And for z equal to infinity, right, your x of z will look like k inverse x tilde. Again, right, this x tilde is this and this entry has to be 0. Okay, why is this so? Because of the fact that a point at right infinity. So, right, see, this is also the reason why you kind of resort to a homogeneous coordinate. See, so in order to, right, express a point at infinity, right, what you will typically do is forget about this particular x, y and all. So, if you want to express a point at infinity, the last element should be 0. Now in this case, right, this is the k inverse x tilde stays because of the fact that the relation that this whole thing should map to x tilde is, right, should still be there, right. We cannot have something arbitrary sitting there, because we know that any point projected from that ray, right, if I have to project it to the image plane, it should map to x, y, 1. And to indicate the fact that, right, z is at infinity, in the sense that the point is at infinity, the last element, right, is actually 0. Okay, this is the way you actually represent a point at infinity. The x tilde that is sitting here, that is still to convey to you that this is not an arbitrary ray. This is an arbitrary ray on which any point projected from this ray onto the left camera will always map to this one x, y. Okay, that is the reason why it takes this form. Okay, now. Okay, now suppose I apply, so now I want to know where these 2 points map onto my second image, right, onto the right. So, that will be like P right, and then I need to put this xz, right. So, xz if I put as 0 0 0 1, right. So, this is where the first point, right, which is at origin, right, is going to go, and that will be like what, PR is KL I0, and then what is this, 0 0 0 1. No, 1 minute, not I0, it is RT, no? Yeah, no, oh, I wrote this wrong. This should be RT, no? There is and KR. Yeah, this is not K left. This is KR. KR, RT 001, and therefore, right, this will be like KR into T. Right? What will be this point actually? Epipolar. Yeah, this is where the center is actually intersecting, the other image plane. This is where this epipolar is. And the other point, right, will come like PR acting on, this should be KL inverse, by the way. I don't know, right, where I should consistently maintain that KL inverse, otherwise there will be confusion. KL inverse x tilde 0, and that will go like KR RT KL inverse x tilde 0. 0 is a scalar, by the way. Okay. So, this will be KR R KL inverse x tilde. Now, what is the inverse of an upper triangular matrix? Is it upper triangular or is it lower triangular? Lower triangular? No, it's upper triangle. Anyway, doesn't matter. Just wanted to, was curious. Okay, so KR, R, KL inverse. Hey, wait a minute. What did I do? X delta, yeah, right? This is how it is, right? Okay. Now we have, right, one point is this, right? This is the first point in the second image plane. This is the second point in the, again in the say right camera, and the line passing through them is what we want, right? Is what we are interested in, right? That is the cross product of these two chaps, right? So that will be your right, say, epipolar line for that point. Okay, again, right? It's not for anything. Yeah, it's for x tilde. So the right epipolar line for x tilde is then given by let us say, what did we call represent L dash, right? That is what we said. Okay, L dash is equal to, what did I have? KL, KRI. Okay, so what is that? KRI? KRT. Oh, sorry. Yeah, it's a translation. KRT cross product. What is the other one? KRR, KL inverse x tilde, right? X tilde. Now KR is actually a matrix, right? What size? 3 cross 3, right? And there is a result in cross product, right, which is a standard result. So you can just take this for granted. MA cross MB, where M is a matrix and A and B are vectors. And does anybody know this property? Okay, I don't know how many of you remember all this. I don't remember, but this is what it is, A cross B. Okay. So this KR being actually common to both. So what we can do is we can write this as KR minus transpose. Okay, this is not that vector. Okay, this is transpose. Yeah, exactly. M inverse transpose. So it's minus T. So it's like KR inverse transpose. Okay, KR inverse transpose, and then A cross B, right? So that will be T cross R KL inverse x tilde. See, x tilde is actually 3 cross 1, and therefore, right, you can see that, right, I mean, everything matches, okay, dimension wise. But this itself, right, I mean, we saw, right, that, okay, right, that there is a way to kind of say write this. So, yeah, exactly. So we'll just go and use that, and we'll write this as T cross, right, which is that skew symmetric matrix that you can derive out of the 3 components of T, right, into this vector, right, which is R KL inverse x tilde. Okay, this is actually 3 cross 1, this is 3 cross 3, this is 3 cross 3, and therefore L dash is of course 3 cross 1, right? That's that L1, L2, L3, whatever, for that epipolar line. Now, see, if this is all K, okay. Now, if you, this product, right, this Tx into R that you see here, Tx into R, this is called this essential matrix. Whereas this product, right, which is like KL or whatever, KR minus T, T R, KL inverse, right, this is called the fundamental matrix. It's called the fundamental matrix. Or in other words, right, you can write this as L dash is equal to the fundamental matrix X multiplying x tilde. So you see, right, so what it is doing is x tilde is a point in your left image, left camera, right. You act, if you knew the fundamental matrix, we don't know F as yet, it's basically a 3 cross 3 matrix, and this is 3 cross 3. Now, if you had the fundamental matrix with you, then if you simply applied it on a point on the left image, then it will tell you to which epipolar line it maps to in the, say, right image. It does not give you the point in the right image. That is why I said homography relates a point to a point. Here, this will take a point, map it to a line, right, which is the right epipolar line corresponding to that point, which also means that if you are looking for a correspondence search, you should be searching along that line, and that line can be at any arbitrary angle in the second image. Right. And one more thing, right, which you also understand is that if the see, right, I mean, in this case we say that x tilde dash is actually a corresponding point of this one x tilde, right, in your, say, in your right image. What does that mean? That actually means that if you took dot product of x tilde prime, right, with this line, okay, that should be 0, because that point should lie on this epipolar line if I knew the correspondence. Right, if I knew the correspondence that x tilde maps to x tilde prime, then x tilde prime should be somebody that lies on this epipolar line, right, because it is that, right, one of those points is my correspondence, and I actually know the correspondence. But if I knew the, in fact, right, this will be true for any point on that line. Any point x tilde dash that lies on that line will have to satisfy this. In particular, if that is a corresponding point of, say, right, x tilde, then yeah, right, I mean, so what you can write is, you can write x tilde dash. If x tilde dash is actually a corresponding point of x tilde, right, then f x tilde is equal to 0, right, because this is a transpose, x tilde transpose f x tilde. So, this is, right, dot product of right, I mean, right, simply a dot product of line with that point, right. So, it is just making sure that if that point lies on that line, then it is a dot product with that line should be 0. Okay, and this equation, that is why I said that we should not think that right, it is actually a relation between 2 points or something. It is more a relation between right, between an epipolar line and a point. Okay, and this also, right, leads to certain right, what do you call, interesting properties for the, say, fundamental matrix. And in the same way, right, I mean, if you wanted to come from the, yeah, by the way, right, I mean, if you wanted to come from the right to the left, then what would happen? I mean, if I had a point there, let us say x tilde prime, and I wanted to find out, right, what is that, say, epipolar line, I have the, right, fundamental matrix. So, right, one way to look at it is take the transpose of this, right. So, that will be like x tilde transpose, what is this, f transpose x tilde dash. Right, and you can think of f transpose x tilde dash as the, right, as the epipolar line in the left image plane, right, and this dot product with x tilde, right, which is a corresponding point, should be 0. So, in that sense, right, so this is f is a fundamental matrix going from, if you look at the ordering, f is like PL to PR, right, f is like, f takes a point from the left image plane, from the left camera, maps it to an epipolar line on the right camera. So, in that sense, I mean, if you want to just remember the ordering, right, f is like PL to PR, whereas f transpose is like PR to PL. So, f transpose will be like taking a point in the right image plane, and then kind of, right, mapping it to an epipolar line in this left image plane. So, both, so, right, this is also fundamental matrix, that is also fundamental matrix, except f transpose operates between PR and PL, f operates between PL and PR. There are a couple of properties of this, right, which yeah, which I think, which we can go through. So, first claim is that the epipole, right, is in the null space of f. See, f is already a fundamental matrix, and right, because it has been arrived at using homogeneous coordinates, f itself can only be found up to a scale factor. That means, even though there are 9 elements sitting inside it, actually only 8 are unknowns, because you can only find it up to a scale factor. But now there is one more thing, right, which is now entering, which is that the epipole in this is in this one null. I mean, it's basically a null vector of f, right? I mean, how do you arrive at this? So, sorry. No, yeah, no, yeah, but you need to show that, right? I mean, you need to show that, right? I mean, f acting on e, right, should be actually 0, right? So now, in order to show that, right? So what this means is that, let's say, right, for so for any point, let's just kind of look at this. So for any point x tilde other than this epipole, okay, that means in the left image plane, right? If you take any point other than this epipole E, okay, we know that the epipolar line, is L dash is equal to f x tilde, and this is fine. And we also know that, right, what do we know? See, for example, for any point, right, x tilde other than the epipole. So right, so I am here, right, and let's say, right, I mean, I have my camera here, right, and then you have the other camera here. So I have my right epipole here, and then similarly, right, you have something like an epipole here. Okay, I mean, this is, so you have this, and when you actually cut this, right, I'm not showing it precisely, but then, right, wherever this cuts this image plane, this diagram is not good. The other one was better. Okay, now you have this E, right? Now what it is saying is, we know that the right epipolar line L dash is equal to right fx tilde contains what? The right epipole, which should be E dash, right? Contains the epipole, E dash. Right? Why is this true? Because for example, right, right, any point you take here, it'll actually give you even a say epipolar line here, and because of the fact that all rays from, right, wherever they come. So for example, right, I mean, you have the camera center here, there is a ray that's coming here, because of which you have a point here. There could be right, I mean, another ray, right, which comes from there, that also has to come through the camera center. Therefore, for this point, right, you may have an epipolar line. For the other point, you may have an epipolar line. But all these epipolar lines, right, I mean, because of the fact that right, they all have to kind of say converge, right, they all have to actually converge at say E dash, right, because they all have to contain E dash, right, because all of them meet at this camera center, right, and therefore one of the points that you can always project from C to C dash, right, is this guy, is this E dash, and therefore E dash will sit in every one of them, right. So whichever extra, and we are kind of, right, deliberately avoiding taking E, because for right, we want to show it in general. So for example, right, I mean, x tilde other than the epipole, we know that the right, epipolar line contains this epipolar this one, right, epipole E dash, or in other words, E dash transpose, right, f x tilde, right, is equal to 0 for all x tilde. Right, I mean, and if something like that happens, right, what does that mean? That basically means that E dash f transpose, right, should be 0, or in other words, you can write this as f transpose, right, E dash, right, is equal to 0. So which basically means that right, E dash is in the null of f transpose. Similarly, right, if you just operate the other way, right, you can show that fe is equal to 0, or E is in the null of f. So what this is now further saying is that your f, right, originally you had 3 cross 3, that means there were 9 unknowns. First of all, homogeneous representation, therefore only say 8 unknowns, and right, because of the fact that right, the epipole should be in the null of f, therefore it actually becomes rank 2 now, and because of which your unknowns actually reduce to 7, okay, instead of 8 for f. Now, one interesting thing, right, which you can actually do is the following, right. I mean, what this also means is that, some people talk about this view synthesis, right. So it's like saying that, I mean, once you understand this geometry, what it actually means is that, right, suppose I have a camera here, and and I have a scene, right, and yeah, so let's say, right, I have some scene point here, and then here is my camera. Now suppose I asked you, right, And okay, right, assume that I have a second camera. Of course, we still haven't shown how to compute depth, right? We have to do that. But then, right, assume that I have the stereo pair and I can compute, a disparity. We'll show that, right? I mean, we haven't shown that yet, but yeah, right. You just have to search along that epipolar line to kind of get that disparity. Now, once you get actually a depth map, right, which basically means that right, from this camera center, right, what is the z value of right each of these points. Okay, that's what you want, right? I mean, eventually that's what you mean by actually depth. If you have that, right, you can even ask, for example, right, I mean, if I had virtually, right, if I actually place a camera somewhere here, I don't even have a camera there, but I can virtually place a camera here, and I can ask, what will this actually scene look like, right? That's called kind of say novel view synthesis, right? So it's like a view, right, that you have not seen before, the camera has not seen before, but you want to kind of say do that. I mean, how would you do that? See, you go like this, right? So you have, right, what do you have? Right, I mean, x tilde, right? You have like p left, right? I0, right? X tilde, which is actually a 3D coordinate, and right, and this guy, right, which you want some x tilde dash. So you want to know, right, where this point will go. See, what does it effectively mean? This is not a homography anymore, right? This involves a depth now. This involves a full blown 3D now. Okay, you can't use a homography to get there, but you can still ask the same question. There we did, no? We said that we wanted to synthesize a new image. Can I rotate? Can I do all that? Right? That we did. A similar question you can ask here. Can I go from one view to another view? But then the scene is 3D now. So now the point is, right. So the point is, I want to know where will this x tilde map, that is like say x tilde dash, and I want to know what is the intensity to assign to it. The intensity assignment looks kind of straightforward because I know the intensity at say x tilde, and if I know, right, where it maps, then I can actually map that intensity there. But then the point is, right, how do I get there? So if you look at it, right, now, if I know the R and T, because right, that is something that I have to give. I have to say that I keep the camera at some R and T, right? That's not unknown. It's like view synthesis. So I say that I pick my R and T. I say that I keep my camera there. So which basically means that my okay, now this is KL. Okay, this is not PL. This is KL. And then in this case, right, what do you have? You have like KR, and then RT, and then you say, right, x tilde. Okay, now given that, right, I mean, okay, there are actually, right, two ways of doing it. I mean, one, let me just give you the intuitive feel for this. So what this actually means is that, I mean, x tilde, because you now know, right, because of the fact that 3D is already computed, right. So you know your say XYZ corresponding to every x tilde here. This is if you have the depth map. I'm saying this is not like without the depth map. That's why I said I have a stereo pair. I've computed my say depth map, and having computed the depth map, it allows me to now synthesize new views now. So what this means is that means is that, right, I mean, if I kind of right have this x tilde right here, and if I kind of know these values, which I know in this case, right, because I know, right, what is my XYZ, and I know my R and T, I know my say, right, camera intrinsics, I know where exactly it maps, and then the intensity, right, I can get because of the fact that I know the intensity at actually x tilde. You don't have to go through actually TD, actually a 3D. I mean, right, you don't have to go through x tilde. You can actually map them such that you can go across these coordinates through the image coordinates also you can do. But I just wanted to mention this, that, right, once you have a 3D, right, it gives you so much power. That's the reason why, let's say, people do all kinds of rendering and all, right. They show that, right, I mean, the object will look like this from here, look like that from here. All that is possible because of this, right. All that you need is the pose of the camera, right. So once you have a depth map of something, right, then all that you, in order to generate a new view corresponding to, or generate an image corresponding to a new view, all that you need is a depth map and the pose with respect to some sort of, this one, a reference position. If you have a reference camera with respect to which you have a depth map, then you can always seek a new image corresponding to a new view. All that you need is a depth map and this pose. Okay, if you can do that, then you can actually synthesize new views and all, which probably you would have seen somewhere, read somewhere, but this is the underlying math that actually governs it. And I leave it to you to show that you can actually relate them through x tilde and x tilde prime also. It does not necessarily have to come through x tilde, even though, right, I mean, you can kind of see that, right, from here you can. I mean, all that you have to do is, write up x tilde as x, y, z 1, and then it will become like rx, and then you can invert it, right? You can do all that, and then just substitute for x, y, z, and then you will get everything related, right, in terms of right, x tilde. So there, right, what you tell is x tilde prime, it will automatically give you x tilde prime expressed in terms of x tilde, but through the post matrix and through the camera intrinsics. Right, you'll kind of directly get x tilde prime without even going through. You're indirectly going through x, y, z because you have that, right? That's the reason why you're able to do all of this, but you don't have to do it through this. You can directly relate, just like you had a homography thing where a 2 image coordinates, even for this called view synthesis, right? So even view synthesis, and this is actually called warping. Right? I mean, if you kind of remember, I'd used this warping and I'd said as loosely that, actually when you do homography, it should not ideally be called warping, right? Warping actually means 3D and post. Okay, that is when people, when somebody refers to warping, he is meaning that there is a 3D world and you're trying to warp one image to another, and that warping cannot happen with a simple homography. That warping can only happen like this. It can only happen with the camera poses and then actual let's see, right, the 3D structure of the scene. If you have the geometry, then you can do. Okay, so we'll stop here, and then I just want to take some special cases which I thought we'll do next class.